Good morning, everyone. I hope I'm audible to you. Okay, okay, let me share my screen first. Okay, so the last class we have completed discussing about the sedimentation aided with coagulants, right? So there we have learned how you add coagulants to water to make the very finer suspended particles to settle down by forming some flocks. Yes, and that water, after the flock is created, so the suspended particles, they settle down, they tends to settle down there, and after that it is passed through the sedimentation tank, and that water, it flows to now a filtration tank. Okay, filtration part. So that water which it comes from screening and sedimentation, the screening and sedimentation, it though it removes the suspended solids or these organic matters present in the water, but then also after doing the sedimentation of aided with coagulation process, then also very fine suspended particles, they and also some of the bacterias, they are not removed by the process of coagulation process. Okay, so after doing screening, after doing sedimentation, then again you added coagulants, but then also the very fine, there are very fine suspended particles which are in flocculated form because you have used coagulants there, and also the bacteria might be also present there. Okay, so to to remove, or you can reduce the impurities that are present there, and to make the water drinkable, so you have to filter the water. Okay, so you have to filter that water which is coming from the coagulation process, like through there are beds of granular material. Okay, there will be granules, aggregates, you can say. Okay, so you have to pass the water through the beds of granular material. There will be sands, there will be aggregates. Okay, so all these materials are there, so you have to pass the water from there. So that process, by which you pass the water through such a granular material, it is known as your filtration process. Okay, so this filtration, it also helps in removing the color or turbidity or other all, and also the most mainly is your that they remove the pathogenic bacteria that are present in the water. Okay, and also the very fine suspended particles after the formation of flocks. So basically the filtration, they are like the types of filters, you can say there are two types of filters that are used most in the while treating in the municipal water supplies. So what are those? Number one is your slow sand filter, and the second one is your rapid sand gravity filters. Okay, slow sand gravity filter and rapid sand gravity filter. Again, there is another one, that is another one that is known as your pressure filter. Okay, pressure filter is also there, and this pressure filter, it works under your pressure. And slow sand and rapid sand, they works under gravity. So the name is slow sand gravity filters and rapid sand gravity filters. Okay. So this pressure filters, or these are generally used for, like small plants, or you can say for these industrial supplies. Okay. So okay, so what about the slow sand filter gravity filters? Okay, so this slow sand gravity filters, also you can say the slow sand gravity filters or slow sand filters. They are actually, they have the capability of removing a very large percentage of impurities and bacteria that are present in the water. Okay. Like if you compare rapid sand gravity filter and slow sand gravity filters, comparing both of them, the slow sand gravity filters, it has a tendency of removing a very large percentage of the impurities and the bacteria that are present in the water. Okay, but then also, like these slow sand filters, it gives it has become obsolete nowadays. Okay, and these slows and filters, they give a very slow rate of filtration. Okay, you can around, you can say that is 130, 1 by 30th of dose of your rapid gravity filters. And also these slows and filters, they require a very large area for their installation, and also they are very very costly. Okay, so like nowadays what is happening is that after your filtration process, you are doing a disinfection process also. Disinfection treatment is also there. So as nowadays disinfection is there, so the the workload on the filters, it has become nowadays a little bit less, because too much purification, or the maximum removal of bacteria in the filtration part is not necessary nowadays, since your disinfection process is already again there after your filtration process. Okay, so nowadays what is happening, these slows and filters, they are becoming obsolete now. In industries or municipal supplies, they are not using the slows and filters, because what is the reason? Because these slows and filters, they require a very large area for their installation, and again they give on the other hand, they give a very slow rate of this filtration, and also they are very costly. Okay, so that's why to nowadays, the in the modern treatment plants, the rapid gravity filters are, it is adopted universally. Okay, so what is happening, that the water from the like a clariflocculator, or you can say the coagulation sedimentation plant, the water from there, it is directly fed into the like rapid gravity filters, and the whatever result you will get from the rapid gravity filter, so that water, that resultant water, it will be disinfected by using some disinfectants for the complete killing of your germs and also the bacterias. Okay, so this is all about your filtration, like the slow sand and the rapid gravity filters. Okay, but now before going to your slows and filters, we will be learning some theories that are like used for filtration. So what are the actually the theories behind filtration? Okay, so number one is your mechanical straining. You see, like the suspended particles, those are present in the water. So and those are those particles which are the size is bigger than the size of the the sand is there. So sand, the bed level of sand is there, so the voids, the size of the voids of the sand, if the suspended particles size, it is greater than the size of the voids of the sand layers, so what will happen, the suspended particles, it will obviously, it cannot pass through the voids. Yes, it will be stuck in them. Yes. So if the what I'm trying to say is that if the suspended particle size it is greater than the size of the voids that are in the sand layer, so obviously the suspended particles it will not be able to pass through the voids and they will get stuck in the voids of the sand layers. Yes. So what will happen? The resultant water it will be free from them. Okay, then what will happen is that most of the particles like those are removed from the upper sand layers, and the particles which are arrested in the in the coagulated flock form, okay, they form a very mat like topping above the bed. Okay, so this will help in your straining out the or removing out the impurities. So that is your mechanical straining. And now second one is your flocculation and sedimentation. Okay, so also it has been found or it has been noticed that the like just now we told that if the suspended particles size it will be greater than that of the voids sand layers, but now here in flocculation sedimentation it is also been seen that the filters they are able to remove the particles of smaller size also, like the particles are smaller size but the voids size are the greater. Okay, the filters they can remove like those particles also, those sizes smaller than the size of the voids. Okay, so what happens here is that the colloidal matter that are stuck in the voids of the sand layers they form actually a like gelatinous mass. Okay, they form a gelatinous mass or also you can say a flock, and this gelatinous mass they what they will do, they will attract the other finer particles. Okay, so those when it attracts the other finer particles, so those finer particles it will settle down in the voids and they can be removed finally. Okay, so that is your sedimentation, flocculation and sedimentation. Then number three is your biological metabolism. So you see in that filter, there are some microorganisms and bacteria present there. Yes, there in the voids of the sand, there are microorganisms and bacteria present. So these microorganisms and bacteria, they need food for their survival. So how they will survive? They need some food. Yes, so these microorganisms or the bacterias, what they do for their survival is that they utilize the organic impurities. Okay, they utilize the organic impurities like what, like in the water algae are there, planktons are there, so they will utilize such organic impurities and they will convert those organic impurities into harmless compounds. By what? By the process of biological metabolism. So this the all the in the water or in the sand voids whatever harmful organic compounds are there, so now they are all turned into all harmless compounds. Okay, and these harmless compounds they they form a layer on the top. Okay, so this layer it helps in like straining out the impurities or also they absorb the impurities. So finally you can say that the process of biological metabolism, these impurities are being removed. Okay, so last one is your number 4 is your electrolytic changes. Okay, so here what is happening is that we know that the filter it helps in purifying the water by how, by that they change all the chemical characteristics of water. Okay, so what happens is that the sand grains, okay, the sand grains or the sands that are present in the filter media, okay, and the impurities that are present in water. So both these impurities and the sand grains, they carry, electrical charges. Those are of opposite nature. Okay, so this, when these impurities and this filter media or the sand grains, when they come in contact with each other, so what will happen, both the charges will get neutralized. Okay, since they are carrying both opposite charges, so when they come in contact with each other, both the impurities that are present in the water and also the sand grains or in the filter media, so when they come in contact with each other, what happens, the electrical charges will neutralize each other. Okay, and when the electrical charges are neutralized, so they will change the character of the water and they will make it pure. Okay, then again what happens is that after a certain period of time, this electrical charges, since they are neutralizing each other for a very longer period, so after a certain time, what will happen, the electrical charges of the sand grains, it will get it will be almost nil, or you can say it will be almost exhausted, or it will get finally exhausted. Okay, and so you have to refill that, you have to restore the electrical charges. How will you do that? So you, if you clean, when you clean the filters, so the electrical charges, it will get restored. So that is your electrolytic changes. Okay, so this all four is your theory of filtration. Okay, next is your, now we have to know, we have known what is filtration, we have learned about the theories behind filtration, but now we have to know what are the filter materials that are being used in a filtration process, right? So it is filter media. Okay, it can be either sand, that is your, might be your fine aggregates or coarse aggregates. Yes, so yeah, again there is a gravel. Yes, so all these things are there. So first of all we will learn about the sand. Okay, so this sand, actually these are obtained from what, these are obtained from rocks. Okay, so this sand that are using in your filter media or filter materials, so those are actually obtained from rocks. Like what kind of rocks, like quartzite is there, you have learned about all this in geology. So quartzite is there, so all these are obtained from there. And also this sand, it should have some properties, it is having some properties. So what are those properties of sand that are used as a filter media? Okay, so number one, you see, it should be free from dirt and other impurities. That is the first property. Okay, it should be free from dirt and other impurities. Number two is your, it should be uniform in nature and size. So it should be uniform. Okay, not like one size is small, the other is big. So it should be, like uniform nature, and it should have the same sizes. Then number three is your, it should be hard and it should be resistant. Okay, number four is what, it should be such as not to lose more than 5% of its weight after being placed in hydrochloric acid for 24 hours. So if you put the sand in hydrochloric acid for 24 hours, so the sand, it should not lose more than 5% of its weight. Okay, so all these four are your characteristics or properties, you can say, of sand. Okay, now how to measure, or how to, if you have studied your soil mechanics, you know these terms. Like this sand, it is measured by a term called what, effective size. Okay, so you can measure the sand by a term called effective size. So what is the effective size? There are certain numbers, if you can remember, there is D10, D60, D30. Okay, in soil you have learned. So what is D10? So here the effective size is used as your D10. Okay, so that means D10 is what? That is the size of the sieve. Okay, in it will be in millimeters. Okay, through the sieve only 10% of the sample of sand can pass. So that is your D10. Okay, and here the effective size. Okay, here like this, you have to select the effective size in a very appropriate manner, because if the effective size is very very small, you are choosing the effective size to be too small, then what will happen? The filter, it will be clogged very frequently. Okay, and then if it is clogged very frequently, then that will give you very low rate of filtration. And again, if you choose a very large effective size, then that will, what will happen? That will permit the particles and the bacteria to easily pass. So that is of no use, like that will not retain any impurities or any bacterias. Okay, so like the choosing of the effective size of the sand is a very important thing. So here, what is the effective size of the sand? It should, in slow sand filter, it will, or it should vary from 0.2 to 0.4 millimeter. And for rapid gravity filters, the value, it should vary from 0.35 to 0.55 millimeter. So this line you can see here. The value of D10 for sand to be used in slow sand filter, it will be vary from 0.2 to 0.4, and for rapid gravity filters it is 0.35 to 0.55 millimeter. Okay. Okay, next is your there is again one term called uniformity coefficient. So since we have read in the properties of the sand that the sand size, it should be uniform in size and in nature. So how will you measure that uniformness? Okay, so that is again measured or expressed by a term called uniformity coefficient. Okay, so it gives you the uniformity in size or the degree of variations in sizes of the sand particles. So the how is it is expressed? It is expressed as D60 by D10. Okay, it is expressed by D60 by D10. Okay, and how it is defined? It is defined as the ratio of the sieve size through which 60% of the sample of sand will pass, okay, to the effective size of the sand. D60 is what? D10 we have learned that here, like only 10% of the sand can pass, and D60 is 60% of the sample of sand can pass. Okay, so this D60 by D10, it again, it has a value for slow sand filter and for rapid gravity filters. So what is the uniformity coefficient value for slow sand filter? It is 1.8 to 2.5 for rapid gravity filters, and sorry, for this is slow sand filters 1.8 to 2.5, and for rapid gravity filters the value is 1.3 to 1.7, the uniformity coefficient. Okay, remember these values. Okay, so this is about your sand. Now we come to gravel. Okay, so the gravel, which is used, it is used below the sand. Okay, first there will be sand, then below the sand it will be gravel. So what is the property of a gravel? So the gravel, it should be hard. Okay, it should be very hard, it should be durable, and it should also be free from some impurities. Then the shape should be properly rounded. Okay, and it has a density of 1600 kilogram per meter cube. Okay, then gravel, they can be of different sizes, and they are put in layers of three or four layers, they are put in that way. and each layer it is of 15 to 20 centimeter depth. Okay, so at the coarsest size, that is the biggest size, that 20 to 60 millimeter, it is placed at the very bottom layer, and above the bottom layer, above the coarsest size, the finest size is put there. So that is your 3 to 6 millimeter, it is put first, like the coarsest gravel will be put, then above that the finest size will be put of the gravels, then above that the sand is put. So this is your like gravel, the properties you have to remember. Okay, so next is your types of filters. Okay, now we already know that there are three kinds of filters. One is your slow sand filter, rapid gravity filter, and your pressure filter. Okay, but the classification is again of two types. If it is based on, if the classification is based on the rate of your filtration, okay, if the classification is based on the rate of the filtration, then it is of two types, that is slow sand filters and rapid sand filters. Then rapid sand filters can again be divided into two parts, that is your rapid gravity filters and the pressure filters. Okay, and now if you classify it on the base of like considerations of gravity and pressure, then it is again of the filters are again of two types, that is your gravity filters and pressure filters. And here the gravity filters are again subdivided into slow sand filters and rapid sand filters. So you can see in this classification that all these slow sand, rapid sand, and those are it's coming twice. So it is important to learn about slow sand filters and rapid sand filters. Okay, so now we will be learning about the slow sand filters. So already I told you, nowadays the slows and filters, it has become obsolete nowadays. Okay, the municipal supplies are not using slows and filters to treat, but then also like in some smaller plants, or like at warm places where the filters are not required to protect from freezing, so in all those places still slows and filters are used. Okay, those are still used. And now uh, the construction of slows and filters, you please go through this one by yourself. This is construction of slows and filters. The tank, it is the typical section of the slows and filter is shown here. And what are the things that are present in the tank. Okay, what things like inlet chamber is there, then what is the head of loss of filter head, what is the sense depth, what will be the gravel depth. Okay, all those things are discussed here. So what is the tank size, what will be the filter medias that are present. So all these things are explained here in the construction of slow sand filters. Okay, so you please go through this part by yourself. Okay, I will not be going it through. You just read it once and you will you remember the values, if there are some values are also there. Okay, so we will be coming next to or numerical. Okay, okay, first of all, then last one I will explain, that is your uses of slows and filters. So where are basically slows and filters used? So already told that the slows and filters, these are generally used in smaller plants, or for the waters which have very low colors or low turbidities, or there is a low percentage of bacteria. So all those things, when it is there, then slows and filters are used. And but this because of their the smaller rate of filtration, and they require a huge area, and they also require a very large volume of filter materials. So for all those things, it becomes very costly, and also these are very uneconomical for, for large scale industries. You cannot spend so much of, your economy for uh, buying all this materials. Okay, also they need a very large area. So for all those things, the rapid gravity filters, they are now not used, as already said. Okay, so now we are coming to the numerical related to slows and filters. Okay, so before doing this numerical, I would like to suggest you to, like, you after the class, you go through the constructional details of the slows and filter. Okay, so it might help for some one two values might be there. So okay, so this question is that, like, you have to design six slows and filter beds you have to design. Then the details are given, like the population is given to be 50,000 persons. Then what is the per capita demand of each person is your 150 liters per head per day. Then what is the rate of filtration? It is your 180 liters per hour per square meter. The length of each bed is given to be twice the breadth, and also they have told to assume the maximum demand as 1.8 times the average daily demand, and also the like 1 unit will be kept as standby. Okay, so now you have to recall your fifth semester. While you have studied your fifth semester, you have learned about the demand of water chapter. So there you have learned about the maximum daily demand, average daily demand, all those things we have learned. Yes, though it is not required for this semester, but for this numericals we have to recall that one. Okay, so first of all, we will be finding out the average daily demand. So what was the formula for average daily demand? It is your population. It is your population into per capita demand. Okay. So average daily demand you have to first find, and the formula is your population into per capita demand. So population is given, value is given, per capita value is given 150 liters per day. So the answer you got it to be 7.5 into 10 to the power 6 liters per day. So now after finding the average daily demand, you have to find out the maximum daily demand. Okay, and maximum daily demand formula was 1.8 times of your average daily demand. Okay, please, if you don't remember these things, then you please go back to your fifth semester notes, and you will be finding all these things. Okay, all these formulas you will be finding there. So maximum daily demand you find out as 1.8 times your average daily demand. That is, you got it to be 13.5 into 10 to the power 6 liters per day. So now in the question, it is given that the rate of filtration, it is 180 liters per hour per square meter. So now you have to find the rate of filtration per day, that is 180 liters per hour per square meter. So you have to multiply by 24 since you are finding it per day. Okay, so 180 multiplied by 24. So now you have to find out ultimately what you need to find out. Ultimately you have to find out the what is the size of the filter beds. Okay, what is the size of the filter beds? That is length you have to find out, breadth you have to find out, all these things. Okay, so for finding, for finding the length, okay, you will be needing the area. Okay, so how to find out the area? So first you have to find out the surface area. So surface area formula was your, like, mdd divided by your rate of filtration per day. So MDD, you got it to be 13.5. You already got the value here. And then you divide it by your rate of filtration, that is 180 divided by, multiplied by 24. And you get it to be something, this value 3125 square meter. Okay. So now in the question, it was told that, like 6 filter beds are there, but out of them you have to keep one filter bed as a standby. Okay, so if you keep 1 unit as standby, then there will be 5 units will be there. Now you have to find the area for each filter unit. Okay, 5 units are there, but you have to find the area for each one of them. So how will you find out? It will be 1 by 5 into your total area, that total surface area that you got, that is your 3125. Okay, so you find out the area for each filter. You got out to be 625 square meter. And now again one condition was given, is that the length, it is your twice of breadth. Okay, length is given as your twice of breadth. So you apply that condition, you know, length into breadth is equal to area. Okay, so here, you know, like length into breadth, it gives your area. So here, since the condition is given that L is equal to twice of B, the condition is given. So in place of L, you put twice of B. Okay, then here B will be again there, and you got the area to be 625 is there. So you just calculate and you will get the breadth to be 18 meter, and then put the breadth value in this condition, then you will be getting the length value as 36 meters. So it means that you have the 6 filter units, okay, with 1 unit as your standby unit, and the size of the filter beds are 36 meter by 18 meter. Okay, so this was your numerical. I hope you have understood. And if you don't also, you if you go through once and if you start doing it in your copy, so you will be understand. Okay, it was easy. Okay, so the meeting, it is going to end now in 2 or 3 minutes. So you do one thing, you join after, you join at again 11:15. Okay, you take a 15 minutes break. Let me also take a 15 minutes break, and you join at 11:15. Okay, I will go through the rapid gravity filter part, and I will finish the filtration part. Okay. Okay, so join at 11:15.